SolidCAM itself. The advanced options that we have in profile operations, inside the pocket operations, we have an advanced field, and I'd like to go through that because there are a lot of things. There are stuff there that people actually do not know too much about, and the idea is to get you to know as much as possible in the program itself. One other thing also, just before we actually go into the webinar itself, is that on our website now, we can be followed on Facebook as well, as shown over here. By clicking like us on Facebook, you'll actually get on your Facebook account constant updates of different webinars, different events that may be coming up. All this will be posted on our Facebook account as well. So don't forget to like us on Facebook to be constantly updated to what we'll be showing, to what we actually have within SolidCAM itself. Now, as for the webinar itself, as for questions during the webinar, if there are any questions during the webinar, just click on raise your hand. In the question area, write the question that you may have. When you finish writing the question, just click on send, as shown over here. And at the end of the webinar, I'll go through all of the questions and try to answer them to the best of my ability. Again, what you have to do is click on raise your hand. In the questions box, write down your question, of course in English, and at the end of the session, after you finish writing the questions, click on send, and then I'll go through the questions at the end of the webinar. Okay, let's get to the webinar itself. The first option I'd like to actually talk about is the option of 3D contour, something that we actually have in our program. We've had it for a while, but I'd like to actually show now how this is used. Now, but before we actually show it on a part, I'd actually first like to show it on a sketch. And the reason for that is I want to make it clear that 3D contour is an option that has nothing to do with the solid part itself. It goes on the edge of a geometry that you may have created, and it can even be done on a sketch. Now, what exactly is 3D contour? Well, 3D contour allows you to create a geometry, a chain geometry, and allows the tool to follow that chain, and the height of the tool at any point is according to where that geometry, that chain is touching the chain at that moment itself. I'll start by creating a simple operation, and I'll just even get rid of this solid just momentarily, so this doesn't confuse you or anything like that. I'll just hide that for the moment, and we just take a look at the sketch that we have over here. If you take a look at the sketch, you see it's actually going up and down in the z-axis, so it's not constant z. I'll start the operation by going into 2.5D, and we have the option of contour 3D. Now, the geometry, just like picking any geometry, any chain geometry that is, I'll click on new. I'll click on the first line to start over there, and I'll just go to the very end and accept that. That's my geometry. Let's choose a tool, and just to start showing it off in the beginning, I'll actually use a chamfer tool as shown over here. And we have our levels. Let's skip this for now, and we'll go into our technology. In our technology, we have the option of having the tool either go on the center of the line itself, on the right-hand side, or on the left-hand side. Let's just go now on the center and click on simulate to see exactly what's going to happen. I'll do this one step at a time. And you can see the tool. Let me get rid of that so it doesn't confuse us. You can see the tool actually follows let me put this on the side view so you can see it a lot better, actually follows the geometry itself. Dead center on the geometry. And the tip of that, the exact center of the tool follows the geometry itself, follows the chain. That's what 3D contour is. Now, if I were to go, for example, on the left of the tool or the right, doesn't make a difference. Then we have the option of doing rough or finish. Let's just click on finish for now. Run my simulation. Again, I'll use a side view. This time when the tool comes down, you'll see that the tool goes down exactly at the side of it. In other words, the edge, this edge over here, is what is in line with this geometry over here. Let me change the tool so it'll look a little different, so you can actually see it a lot better. I'll use a regular end mill for now. And what you'll see is, again, the tool will go down, and you can see this edge is what's following that that particular contour as it's going down itself. Let it go down. Let it go down till the end, and that's exactly what happened. Okay. Now, let me just go back in here again to show some more options that we have in here. We have the option of, in our technology field, going back to the center, whether you want the tip of the tool to go down the center or the center of the tool. You can see the difference in the picture. If I have the tip, if I'm using a ball end mill, you'll note that the ball will actually touch the tip itself. But if I'm using a regular end mill, you'll see that the edge will be actually following that particular line. Let me actually run it right now with the regular end mill that I just showed you now. And this time I'll show the side view of it. You'll see that the tool will go down. And note what happens, and I'll try to zoom into this area over here. What actually happens is the tip is always what is touching the geometry itself. Okay? Let it run down to the end. And as you see, that's what actually happens. The center of the tool is actually up in the air, while the tip is over here. You can actually see that even a lot better if I were to use a ball end mill. If I were to use, for example, a ball end mill on this part, on this geometry, you'll see the tool goes in, and you'll always see that what's touching the geometry itself, right now it looks like it's the center, but once it starts going off to the side, you see the center is not touching the actual center over here. It's not touching the geometry itself, the chain itself. Rather, it's moving towards the side. Always make sure the tip is what's touching the geometry itself. Now, let me bring back the actual part I had here before, and we'll show exactly how I can do this on the part, how I can use this on the part itself. And I'll give an example. I'd like to actually use a chamfer tool to take off the burr off of this edge over here. So I have an operation that I've created already, so I'll just unsuppress it so we can see it. The operation itself, if I were to open up, we have the geometry itself is the edge going over here, which is actually now a 3D contour edge. The tool is the chamfer tool that I showed before, as shown over here. And in my levels, we'll talk about that in a moment. Going to my technology, I want to work on the left-hand side. Now, however, since I do want to do a chamfer on the part, we have the option of doing chamfer. By clicking on chamfer, as shown over here, we have a chamfer field telling us what diameter of the tool is actually going to be cut. Now, how deep am I actually going into the edge itself? That's in my levels. What's the depth of my chamfer, as shown over here? So I'm going to actually be going down 0.5 millimeter into the material itself. If I were to run my simulation, and I'll actually use now Solid Verify to show this, you'll see my tool will actually go down, and I'm going to zoom in now to this area. What you're seeing is the actual 1 millimeter of the diameter touching the edge, going down on that edge a total of 0.5 millimeter. Let's zoom out a bit and let it run now until the very edge. You can see that it created a chamfer around that edge. The same thing can be done on this part at the very top edge. Let me open up a different operation that I have over here. If I were to open up the operation, what you'll actually see is my geometry going around the edge of the part itself over here with this little dip over here. So that makes it a 3D contour. Again, I'll be using the exact same tool I used before. My technology, I'm using chamfer on the left-hand side. And my chamfer diameter, I'll be using 1 millimeter of the diameter of the tool. And again, over here on my levels, you'll note that I'm going 0.5 millimeter into my edge. Again, let me show the simulation of that particular operation. The tool will go down, create a little bit of a chamfer and that entire edge, including this area over here, which is actually going down 3D. So there are other uses of 3D contour itself, but this is one of them. And you don't necessarily have to use our 3D options that recognizes the target itself. Is not necessary in this case. All you need is just the edge. Even a regular sketch will do as well. Okay, that's for the 3D contour. Let's go now and look at some of the advanced fields that we have inside our operations. I'll open up a different part that I have over here. And the first option I like to talk about is sorting. Now, let me actually delete what I've done here. Actually, I'm going to start this from the very beginning. I have a series of pockets that have to be milled out on this part itself. If I were to look at it over here from the top view, you can see all the pockets that I have over here. Now I'll start the new operation of pocket. And my geometry, to save time, I've already created the geometry beforehand. Let me just show it to you. And on purpose, I did not go in order. You'll note my first one is over here, my second one is somewhere around over here, and so on and so forth. And it was actually jumping all over the place as far as the order of my chains goes. And I did that on purpose to bring out a point. Now, my tool, I'll use a 6 millimeter end mill. Then just go into my levels, going down up until that surface over there. We'll go down in one step, and let's do save and calculate to see, and a simulation to see our simulation of this geometry itself, this pocket itself. And as you see, it's actually jumping all over the place according to the actual order that the geometries were created in. Okay, and Obviously, this is not the way I would like to work at all. I would actually like to have it go in the shortest order as possible. Because going this way could actually waste time. This is maybe a huge part, and if it's a huge part, every single time it goes up and goes across to a different area, that's an issue of time. And I'd like it to actually work is go from the very beginning, going across, back and forth, this way using the shortest route between each one of those chains. So for that, we're going to go in our technology field and open up the option of advanced. Now, this is the actual whole field I want to talk about, this area over here. And for this part, I'm going to use the option of advanced sort. By advanced sort, it allows me to actually choose how do I want to sort out my chains. Since I said I want to go from the bottom over here this way and then back and forth, choosing that particular shortest way, I'm going to use this option over here according to this particular map as shown over here. I'll click on OK. Let's run our simulation, and you'll note it's not going to do what I actually thought it was going to do. It's starting over here, then jumping back and forth between different parts over here, not going in order. And the reason for that is very simple. If I were to take a close look at my pockets as shown over here, and just put this off to the side for a moment, you'll note that these pockets are not aligned at all. Since these pockets are not aligned at all, the very lowest one is its first pocket. Okay, hold on just for one moment, please. Okay, sorry, I had a little technical problem over here. The lowest pocket is the one where it starts. Then it goes one to the next line. So let me just run it again. And you'll start. It started over here, and then going back and forth, keeping on line. This one was the first one, then it was the second one, then the next one on the line. And same thing with the next lines up and go. Now, what I'd like to actually do is, like I said, I'd like to actually have it start from the beginning and go straight, because this is not exactly the most efficient way to work. So let me just stop my simulation, go back into my advanced sort, and the way to take care of the problem of it not being aligned to each other, because right now it's working exactly the way I told it to do, is we have the option of tolerance. By giving it a tolerance, it allows me to actually deviate from the edges that's whichever one it's within those tolerance. If it stays within the tolerance is the distance over here, it'll work and consider it as if it's in the same row. Let's give it a tolerance, for example, of 3 millimeters. Now let me run my simulation. And what you'll see is as follows. I'll run it a little slow. You'll see it start from the beginning. Whoops, sorry. It starts from the beginning and then goes over to the next one. Exactly now the way I want it. Because the distance between this and the bottom one and all of these is less than 3 millimeters. So consider this all in one line. Finishes this line itself. It goes up to the next one. Speed it up now. Now it's milling out these pockets exactly in the order that I want it. Okay, that was for the first option of sorting. Now the next option I'd like to show you is something called final cuts. To do that, let me open up a different part. And actually there are two things I'd like to show you. One is the angle and one is also the final cuts. Let me actually first start off with the angle option. Now, what I'd like to do in this part is to start off by machining this step down over here. Now, I'd like to run my rough cut on this using a face mill. The distance between this wall and this wall is a total of 80 millimeters. So So I'd like to do a face mill going down just to clear away that material. Now, we all know the problem sometimes with the face mills is that the edge of the face mills, as we'll see in the operation itself, let me just open up the operation. You can see my geometry is at one line. And if we take a look at the tool itself, and I actually want to bring this one in over here so you can see this a lot better. You can see the edge has an angle on it in this particular face mill. And there are lots of face mills that actually look like this. Now, when I go down, let's say every 3 millimeters, I don't want to go, after I pass the first, say 5 millimeters, the length of this cutting edge over here, I'll actually have material that's left over here may end up touching this wall over here, which I don't like, which is not exactly the best thing for the tool itself. So I like to avoid that. Now the way to avoid that usually is that every single time I go down to move further and further away. Now this can be done automatically in our technology field in advanced. If I were to use what we call now wall draft angle, okay, wall draft angle as shown over here, I can just tell it go down 45, as you're going down, also move 45 degrees on a 45-degree angle on the part itself. Okay? Let's take a look what happens. Why did I say 45? Because the edge of the tool light itself, in this particular case, is also 45. Let's just click on OK. Run my simulation. I'll do this using Solid Verify. You see that the tool will go down. Move this off to the side. Bring this up a little closer over here. The tool is going down, across, and as it goes down to the next step, it's actually moving further away from the wall. Actually, I'll show this in our HostCAD using the new option of solid verification in HostCAD. We can actually see this even a lot better. We can see the tool going down, and we can actually see what our line geometry is. Our line geometry is over here. That's the actual wall. Now, what's going to happen is instead of going straight down, it's actually also moving 45 degrees on as it's going down to the side. And as you can see now, we're even getting a bigger angle over there. Notice we're going further and further away from the wall itself. If I were to look at this view over here, you can see that's actually what you see, how it's working. Again, I'll do it slowly. And as you see, as it goes down, it's also moving away. This way, avoiding any kind of contact between this wall and the material that may have been left over there. Obviously, at the end of this operation, you'll need another operation to take the rest of this material off. Okay, now, let me show you a different scenario as far as the angle cuts goes. Let's take a look at this chamfer that we have over here. Now, before I actually use a chamfer tool on this, I'd like to first rough this area out. So if I were to use a regular end mill, okay, I'll use a regular end mill. As you see, my geometry is this edge over here, the inside edge over here, the actual top, not the bottom, but the top over here. The tool is a regular 20 millimeter end mill. Okay. My level is going down up until this edge over here. And in my technology field, again, I've used the advanced mode of wall draft angle. Since this wall here in itself is also 45 degrees, I've written down here 45 degrees as well. And let me just go into my technology. I want to go down every 2 millimeters. Let's take a look at what actually happens to the material itself. You see it's going to go down, and you can actually have a bunch of steps created on that part itself, making it more ready for to actually do your final chamfer. If I want finer steps than that, not a problem at all. I can just take my step down to whatever step that I want. Let's say every half millimeter, no problem. Okay? Run my simulation. Again, let me run it down just a little faster. And as you'll see, again, you'll have that those steps every half a millimeter down on the part itself. Again, making it more ready for your chamfer on that edge. By the way, just for your information, in 2014, we are going to be adding a new operation in 2.5D, specifically designed for chamfer operations, whether it be small chamfers or large chamfers. Just a little something to whet your appetite on to see what some of the things are coming up. Okay, let's continue on now with my last option that I'd like to show you. If we take a look at the part itself, the entire part from top to bottom is a total of 70 millimeters. Now, I like to create a profile operation around the outside, and the operation, actually, I've created it already. Okay. Just a moment, please. I've actually created the geometry already. I think everything froze for a moment over there. Okay, go back here. My geometry is as shown over here, going around the part itself. The tool in this particular case that I have is a 12 millimeter end mill, and note that it's actually pretty long. The depth, like I said, is 70 millimeters. Now, the way I'd like to work, I've written down in my technology area that I want to go down every 10 millimeters. And if I were to run my simulation now, you'll see that the tool goes down every 10 millimeters on the part. But you know, the tool's actually, maybe towards the end over here, I'd actually like to go down in smaller steps. What I want to actually control, the further down I go, the less of a cut I want to take. So what we can do is we can go into our advanced and open up our final cuts field and activate it. Now, I've already created some options over here. What's going to happen is as follows. I want to start off going down every 10 millimeters. And then I want to go down 5. I'd like to actually break it up then afterwards. That could go down 3 millimeter steps 5 times. 5 times to do 3 millimeter steps. Another 10 times to do steps at a half millimeter. And the last 5 steps at 0.2 millimeters. Let's actually take a look at the tool path, and you'll see exactly what I'm talking about. And I'll run this pretty slow, and I'll actually bring my data so you can see exactly the down steps that I have on my operation here itself. We'll start. You'll see right now we're at -10. Next one, -20. Next one, -30. -40. -49. Okay? Look what happens now. Next one, -52, 3 millimeters down. Another 3 millimeters down. And it'll keep on going down every 3 millimeters. Up until the last 5 steps that are left over, it'll do it at every 0.2 millimeters. Sorry, this is 0.3. Now we're actually having, every half a millimeter. And for my last steps, as you see now, it's at 67. 67.5. 68. 68.5. 69. And now it's going to go down, my last 5 steps are going to go down 0.2 millimeters. 69.2. 0.4. 0.6. 0.8 until it finishes it off. In other words, what I've actually created over here is sort of a control of my depth of cut each time. I can start out with a larger depth of cut in the beginning, less over here, less over there, and even less on the next one itself. In other words, I can have a complete control of these step downs that I want to go. This is especially good with deep parts where you want to actually control the amount that goes down every single time, because the deeper you go, sometimes you have more vibrations on the part, it's on the tool and the part itself. This way you have some control as far as the step downs, making it go at different levels as you're going down, less every single time. Okay, so let's just give a quick review now of everything that we've done over here. Our first one we actually showed you was the option of the 3D profile, creating actually a profile step going down, where the tool actually follows the geometry. The depth of cut is actually according to geometry itself, according to the chain that we used. The next thing we talked about, the next option we talked about, was the option of sorting. How do you sort to do the actual milling of these pockets in the shortest path, going from one to the next, how to control the sorting of that. And we also looked at the very end, we also looked at the option of deep final cuts and angle cuts as well. And this we've seen in this option. Okay, as I said, I'd like to open up the floor now for any questions you may have. I'll give you a moment to write down any questions you may have in the actual box itself. Okay. But by the way, on our website, if you go into our website, you'll note in our website itself, we have here a feed for webinars, see it live. If I were to click on it, you can see a listing of all different webinars that we have. Ones that are scheduled, and I'll be scheduling the next one also as well. As well as at the bottom, we also have recorded webinars that I've done in the past. We'll be having plenty of recorded webinars. The ones that we've done in the past will be located over here as well. So if you've missed the webinar, you'll always be able to see them. Pretty soon we'll actually have them all over here, the ones I've done in the past month as well. All of this will be on this page here as well. Okay. As I see there are no questions, that means everyone understood me perfectly well, and I explained it actually very well. Okay. Thank you for joining the webinar, and we will see you at our next webinar next week as well, same time. And everyone have a great rest of your day, and also have a great weekend. So take care, everyone.